going wireless here. We're taking this to the next level, our technology. So I got a few slides for you guys. We're going to have a little short video demonstration at the end, and we're over in the exhibit booth if you want to take a look at some of this in action. Thank you for the introduction. Yeah, I'm a product manager at LitePoint. LitePoint builds test solutions for all different wireless technologies. All those technologies we just got done here and Eric talk about. We certainly support all of those. Because this is an IoT conference, I picked a technology that I think is interesting. It's Bluetooth. Oh, I even brought props. I don't want to forget those. So I want to tell you guys a little bit about Bluetooth and a pretty innovative way that we've come up with recently for testing your Bluetooth devices. Do I make them go forward? I didn't get any instructions on this.
Yes, there is a, that's it, yes.
Okay, thank you. So before I dive into testing, I want to talk a little bit about, let's ask ourselves why we're testing. On one side of the slide up here, I call it the required testing. So if you want to use the Bluetooth logo on your device, they've got a set of tests for you. If the FCC, if you're going to ship it someplace where the FCC cares, which is a lot, they have a set of tests for you. So that's what I call required testing. Actually, there's very little required testing that's being done relative to the other side. The other side is what I call desired testing. It's because you want to improve your quality, you're establishing a brand. I don't care how well you design it, if you're not testing it in your manufacturing line, who's keeping an eye on your CM? So what I'm going to talk to you about here for the next few minutes is about more what I call desired testing. So if you're trying to improve your brand, if you want to see how well your CM's doing, if you're trying to make your design better, this Bluetooth test methodology is going to be helpful for you. Many of these ideas kind of apply to other technologies, but I specifically want to talk about Bluetooth here. The demonstration and over in the exhibit booth is that. Just to be clear, we are talking about Bluetooth low energy. So again, IoT. Many devices transmitting a lot of little bits of data. That's kind of one of my IoT things. This isn't Bose wireless speakers I'm talking about here. I'm talking about everybody has a Bluetooth low energy device with them. Many of us have multiple Bluetooth low energy devices with them. They're about sending small bits of data. I wanted to comment on Eric's report cards there. Those report cards he was giving was the applicability of these technologies for headsets. So hopefully folks picked up on that. You really have to pick, so this is a little bit away from my talk here, but all of these technologies have their place in the world. And so you have to look at your application and decide which technology is right for your application. So for some of those, I'd give Bluetooth Smart an A+. And for other ones, which he maybe gave a high number to, I think we had to make them smaller. But anyways, we're talking Bluetooth low energy, so sensors, beacons, fitness trackers. Many of you have a Bluetooth low energy beacon on your arm right now that's talking to your smartphone. And certainly your smartphone is receiving Bluetooth low energy devices. You might say, but, so I'm up here talking about test. Bluetooth SIG, if you're at all familiar with Bluetooth, you know Bluetooth SIG. They've actually done a really good job. They've got a very well-defined set of test specifications for testing Bluetooth and Bluetooth low energy devices. So you might say, why do I need to hear about another way of testing? Why don't I just use that? It's the de facto standard. It's been around forever. So some of the benefits of it, it's a so well-defined test method. Again, every device that gets a Bluetooth logo on it has to go through the Bluetooth SIG testing. FYI, I think there are more devices shipped with Bluetooth that don't actually use their logo. So I don't know how meaningful that test is that it used to be, but lots of Bluetooth devices, my set of car keys here, Bluetooth chip in it, but no Bluetooth logo on it. So I'm sure they're skipping over that step. The Bluetooth SIG does enable very low-level testing of a device. So you attach wires and you get down into the bowels of your little device and you control it at a very low level. So that's a good thing. If you want to get to that level and you have the ability to get to the level, that's actually a positive. And as far as test equipment goes, LitePoint and a few other test vendors build very good Bluetooth testers for doing the Bluetooth SIG. So you have some variety out there. What are some of the limitations about it? And really, next slide is about what drove us. The Bluetooth SIG tests are really designed to be in a lab environment. So if you look at how you have to do those, the type of tests, how long they take, these are not designed for a manufacturing environment. And quite frankly, they're not designed for many of the measurements that you need to do in an engineering lab even. It requires the device to have special direct test mode firmware. So again, good news, they defined all this. Bad news, that's one more piece of firmware you have to keep track of in your device and potentially load in your device when you're ready to do this testing. It requires the device to have a COM port. So the way this all works is it's got the special firmware in there, and it's monitoring a port, and it says looking for commands, and these commands come in, these special commands come in, and it tells the device what to do. Many devices don't have the ability, when you get done, don't have the ability to actually communicate with them through anything but wireless. This requires a wire. And the last one, bit of my favorite, hopefully Bluetooth SIG's not in here and they're feeling picked on, but you can actually pass your device, you can actually get your Bluetooth SIG certification. You don't even need to have an antenna in your device. So literally they tell you, disconnect the antenna, connect up an RF cable, and we're going to measure the output from the chip. I'm kind of going, you know, well, how can you certify a device if it doesn't even have an antenna? It's clearly not going to work. So I put something together here. So this is one of my props. I wanted to show you guys when you want to just pick a device, if you want to actually do Bluetooth SIG testing, this is the kind of stuff you're going to have to do. I put in a little RJ11, nice. So I have the ability to load firmware into my device. I'm seeing a couple of grins out there. So it's supposed to be a little bit funny. But I'm able to load my device with firmware. I now have a COM port that I can go in and I can control my device. And I scratch the antenna out and instead attach the little RF cable. So this guy's ready to go. I'm ready to go get myself Bluetooth SIG certified. Unfortunately, when I get out to market, my device looks a lot more like this. So this is the device that you're going to be selling. This is the device that your customers are going to be experiencing. And ultimately, I claim your customers are going to care how it performs over here, not performing over here. So what I'm going to tell you about is this new technique. It's really fairly simple. How we can test devices that look like this instead of devices that look like this. Again, it's about improving customer experience, improving quality, helping you guys be successful with a device that actually works. So what were the key drivers here? So we see a lot of these Bluetooth devices, half a dozen of them over there on the other side that we can look at. And if you guys have some devices too, bring them over. We'll test them for you. Literally, we don't need any connections. I don't need to know what chipset it is. If it's advertising some beacons, we're good to go. So many of these devices, no antenna access. Obviously, they have an antenna, and we like to know that it's kind of working. There's no USB, there's no COM port. Some of them maybe have that, but not, many of them less and less all the time. And also we wanted something that is really simple and really easy to use. Many of these are low cost. So, our customers, building devices that maybe cost $5 or $10, they can sell them for $5 or $10. We also have customers building embedded medical devices that go inside your body, and those are tens of thousands of dollars. So there's a whole wide range of different customers. They're all using the same Bluetooth. But we wanted to design a product that's simple enough, cheap enough, fast enough that we can work on the entire range of these products. And so anyway, these were some of the design challenges that we said, we need to solve that because we see a lot of these, and there's no way of doing it today, this over-the-air testing, without these, these things that are attached to it. So I'm going to tell you really quickly just a couple of slides on how this thing works. We're going to watch a little video of it, and hopefully you have a couple minutes to go over the other side and actually see it work. So there's the two ways of testing. I've talked about both of these a little bit, but this is a little bit of a visual that kind of repeats it. It repeats this. So the thing at the top is Bluetooth SIG test mode. You need a wire going into your device to control it. They tell you to use an RF cable to measure it. And typically the device is more open, you know, it's not fully encapsulated because you need access to this stuff. So that's traditional stuff that's been around for years, and multiple vendors build that thing at the top. At the bottom is what we're talking about here. There is no connectivity to the device at all. It's all done completely over the air. These little guys transmit advertising packets. We receive those packets for transmitter measurements. We send it packets for doing the receiver testing. And so far we're the only one that has an over-the-air test solution that does this for Bluetooth Low Energy. I talk just a couple of little, we're not getting too deep on this, but a couple of little details on why this is okay, and maybe highlight a little bit of the limitations of it for you guys. So secret number one is we use these advertising channels. So when I press this little button, it's starting advertising. It's sending out little packets of energy at the lowest frequency, the highest frequency, and one of the frequencies in the middle. So we're about RF testing, transmitter quality, receiver quality, and by testing across these three channels, we feel it gives a good coverage across the entire 2.4 gigahertz band. So one limitation though is all those other channels in the middle we do not test with this method. So we are, you know, I'm fessing up to some of the limitations of this. We are testing on those three channels. If you want to test all the other ones, you got to hook up the wires, and you can do that as well. Our test equipment does them both. But this method uses those advertising channels. We feel it's good because every device supports them, and it's a nice coverage across the entire RF band that these devices use. In a manufacturing environment, that's all they do anyways. They do one in the middle, you know, low, medium, high. So in manufacturing, nobody's going to ever argue with this being enough. In an engineering environment, okay, maybe you want to do something a little more, hook up the wires. Transmitter testing is quite straightforward. You know, if you think about it, this thing's shooting off some energy. I got a little antenna here. I can hook it up to a variety of different pieces of test equipment. You know, I'll just pick a spectrum analyzer, and I can see these bursts coming out. I can measure their power. If I can demodulate them, I can measure some quality. So measuring the transmitter is actually not that, wow, you know, you took up 20 minutes of my time to tell me that. The real new part here that's quite innovative is the ability to test the receiver. And so what we do is these little blue bursts of energy over here are coming out of your device. But let me kind of explain it like this. It sends out a little advertising packet that says, hey, does anybody want to talk to me out there? My tester sends a little message back to it and says, hey, I might want to talk with you. Tell me more about yourself. And it'll respond back with a message that says, here's some more information on me. That's an advertising packet, a scan request, and a scan response. All of these devices support that. That's the mechanism we use for doing the receiver testing. We send a packet to the device, and it acknowledges. That's an ACK. We send 100 packets, and it responded 98 times. Guess what? That's 2% packet error rate. So it's a very simple mechanism. Again, all the devices support it, and it allows us to do not only the transmitter, but the receiver measurements. I forgot what my own slides are now. Shouldn't have put them together so soon. So what can you really do? I mean, this seems a little bit light. Is there anything going on? You know, you can go out and buy these little dongle things for $100, and the price is right, but you're not getting much. What can you possibly be doing while you're just on these advertising channels? And the answer is one heck of a lot. So this is the list of measurement results that we provide. This device right here, so I'll show you a little manufacturing test flow. Actually, our little demo. We got a little short 3-minute demo. We can fully test this thing in like a manufacturing environment, 2 or 3, maybe 4 or 5 seconds. So we can get a lot done very rapidly. Again, trying to keep with the idea of low cost. You want to test it for 20 minutes, I can set up some test flows for that as well. But really, you're getting most of what you need very, very quickly. So in that 2 or 3 seconds, what am I going to report to you from my tester? From a transmitter side, it's power, it's modulation quality, If you know the Bluetooth SIG tests, those words up there are maybe meaningful, but it is the quality of the transmitter and the output power of the transmitter. Down at the bottom, unfortunately, you're staring at me instead of my slide. There's basically two different receiver tests. One of them is packet error rate, meaning I sent it 100 packets and I ask it how many it received, or I keep track of how many it received, and I measure packet error rate. The other one that's under there a little bit hidden is actually a receiver sensitivity. Receiver sensitivity is where you actually search through we adjust our output powers to get down to the point where it has a specific packet error rate that's defined in the spec. So as much as possible, these tests are actually defined by the Bluetooth SIG. You know, it's the de facto standard. I mean, I don't want to put it down. It's a good test, but it belongs in a different part of the test process than is always convenient or practical or even possible. And that's where this other one adds a lot of value. You might say, okay, so I got to go out and buy some expensive test equipment and to run this Bluetooth SIG thing because I'm going to do my Bluetooth SIG testing anyways. And now you're going to make me buy something else to go off and run this new fancy over-the-air thing that you've got. So LitePoint right now is the only one that has an over-the-air solution for Bluetooth Low Energy. But the good news is exactly the same hardware platform. So what we're talking about here, it's a software difference between these two. So from LitePoint, you know, this hardware platform, you use this software, you can test this. If you don't want to test it like that, it's just a different software package and you can do all this over-the-air testing for us. So anyways, basically building on a solution that we already had and finding a way of making it work for this additional testing capability. So, and it's not really that expensive in the first place. Okay, I think this is my last slide, and then I think we're going to do a little short video so you can, it's a 2-minute thing that you can watch me on the big screen, not standing on the small screen. So Bluetooth Advanced is what we call this over-the-air benefit. It's very fast. You'll see some testing done on the video. You can see it next door. You don't have to go through all the things here that you maybe don't want to have to go through because it's in a manufacturing environment, or you just as soon test it once and not test it twice. So all those limitations of the Bluetooth SIG that I brought up, many of those you don't have to worry about now. As far as parametric test coverage, I just put the word good up there because, again, if you want to get to the lowest levels possible, you have to connect wires, you have to control the chip. If you want to do every channel, if you want to do different power levels, if you want to do these crazy long packets, you have to get in there and force the chip to do that. We provide something, it's very fast, it covers the channels, and it provides very good measurements. So we're giving ourselves a good rating on that one. And extremely simple. So because it's over the air, that actually adds a challenge. Anybody that's done any over the air testing, it's the next level of difficulty. The software we provide does provide some very simple routines that help you calibrate for these over the air. Basically, you take a golden dot, you put it into your fixture, and you calibrate your fixture based on a golden device is really how it works. Anyways, we've very much simplified what it takes to do that. I think that was, the guy up there is telling me that was my last one. So he's going to go ahead and play a short video. So I want you guys to be able to see this thing in action a little bit, and it talks a little bit more about the specific solution. So up here, you know, plug in a test product. We're supposed to be telling you about this test methodology, but I want you to be able to see it in action as well. So,
Transmission power, you just say good,
nope, no.
give a unit of measure.
Yep, so you will see, I think it talks a little bit more in the video here, but yes, so when we measure power, we measure every single one of those packets. So you've measured 100 packets, or you tell me how many you want to measure. We will report the minimum that we found, we will report the maximum we found, we'll report the average that we found, and with our application software, you can use your own, but with our application software, it easily allows you to put in pass-fail limits, so you get to decide what's good enough for you. So, no, it's very much parametric. And when you get done, you know, you can have mountains and mountains of data to go back and analyze. I bought, nobody from Tiles here. Actually, it's went out and bought a dozen. So we use these for our little, you know, our salespeople have them for their little demo kits to go out and advertise stuff. But anyways, I bought a 12-pack of them. I thought, you know, just what the heck? I'm sitting in my hotel room one night. What the heck? I'm going to see how these things performed. And sure enough, 1 out of the 12, it should have gone in the trash. They never should have shipped it. But they had no way of, you know, of identifying that. So it was 3 dB. For if you know a little bit of technical, you know, the transmit power from it was 3 dB worse than the other devices that were in that packet. I didn't want that one. That's not the demo DUT that I kept. You know, I gave that one to somebody else. But anyway, so it's yeah, it's very much a parametric, and it gives you real parametric data.
I'm not saying depending on the device you're testing, there's a certain spot that you placed it, so the distance doesn't vary when you get a 10
So if you look at our little demo setup that we have over there, we actually did a little 3D printing of a little plastic jig. You know, it's really for demonstration, but it goes inside my RF fixture so that every time I put it in, it's in the same spot, because over the air, so this guy's done some over the air testing, you know, if I jockey this thing 90 degrees, everything just went to heck on me. So you got to be consistent. If you want consistent results, you have to consistently place it relative to your receiving and transmitting antenna that you're talking to. Yeah. So, do I make the video go? You make the video go? Okay. Yeah. Yeah, go ahead and make it go, and then we'll have a couple minutes of. Hi, I'm Alan, a product manager at LitePoint. Today I'm showing the Bluetooth Advanced Measurement System, which consists of 3 major components: the IQXL-M tester with Bluetooth licenses, the IQ-FACT Plus test application, and an RF enclosure. For today's demonstration, the RF enclosure has an integrated coupler, and you can get these from a variety of different vendors. There's almost no setup required. You simply install the software and connect a single RF cable. Once the system is set up, performing RF measurements is fast and easy. Before we run the test, let's take a closer look at the application setup. This is our application software called IQ-FACT Plus. It is a test manager that allows you to easily configure test flows and set pass-fail limits. In this area, we set up the test flow, which is very simple for Bluetooth smart devices. In this flow, we run a single test that performs both TX and RX measurements. In this area, we configure the test parameters for things like number of packets, path losses, receiver power level, and the RF input port. Okay, let's test our first Bluetooth device. This is a popular fitness device that uses Bluetooth low energy. This RF enclosure has an integrated coupler, so I simply place the device in the enclosure and execute the application. The test will run and perform a variety of verifications against pass-fail criteria that I defined. In this test, we're performing both transmitter and receiver measurements on all 3 of the Bluetooth Smart advertising channels. This takes just a few seconds and gives you high confidence the device is working properly. The application will indicate if the device passed or failed and automatically logs the results in easy-to-use .csv or text file. Let's take a closer look at the results we can generate. In this result file, we see key RF parametric results for transmitter and receiver. Results are reported for all 3 advertising channels. We see packet error rate. For this device was 0%. We see delta F1, delta F2, and frequency drift, which are Bluetooth SIG-defined measurements for transmitter quality. Finally, we see TX power. This is reported as min, max, and average for all 3 channels. A key benefit of over-the-air testing is that configuration and setup is similar for all devices. Running a second device is easy. As an example, here I have an asset tracker. I'm using the same test setup, and I simply place the device in the RF chamber and start the new measurement. The setup will perform the same measurements and provide a new pass-fail indication. Thank you for your interest in LitePoint's new Bluetooth Advanced Test System. Threw in a little multimedia, keep things interesting for you here. So, anyways, that's all I have for you guys. If you have some questions, happy to answer them. Also, as I mentioned, we've got a little demo set up over there. If you've got a little Bluetooth device, we just drop it into the little magic box and test it for you. Yeah.
Can you also test the ZigBee Blade combo chipset in those small channels?
So the tester itself does do ZigBee, Z-Wave, DECT, almost all those technologies he was mentioning except NFC. It doesn't go in that box. But so the tester itself is capable of doing that. This over-the-air thing is a special capability because we're using the advertising channels. We're looking at what we might be able to do with ZigBee, but we do not have that today. But,
It's a combo chipset. It's a soft.
oh,
It's a soft. The blade inside.
so absolutely, yeah. I mean, multiple technologies can exist inside the chipset. One of our customers, an interesting application, but they transmit standard advertising packets. Then they transmit Apple iBeacon packets, and which do not respond for receiver test. And the software is smart enough to go in and say, hey, that's not going to respond to me, so I'm not going to try to interact with an iBeacon. So, so if you're transmitting a little ZigBee and you're transmitting a little Bluetooth, I can find the Bluetooth packets and provide the Bluetooth test. Yes. Anything else?
Okay, thank you
All
very
right.
much.
You betcha. Thanks, sir.